Okay, so good morning. We are starting off today now. It's giving me immense pleasure to be here and speak uh, to introduce about the today morning's keynote that is by Professor Shantanu Chaudhary. He is from IIT Delhi. The title of the talk is Document AI Perspectives and Future, and I would say uh, this is the really most qualified person which we are having to speak on this topic. Um, Professor Shantanu was the consortium leader for the MIT project group on um, robust OCR development, and so that gives him immense qualification and background to be speaking on this topic. So some more formal introductions, like he did his BTech in 1984 from in electronics and electrical communication engineering, and his PhD in computer science engineering from IIT Kharagpur. Uh, Presently, he is a professor in the Department of Electrical Engineering at IIT Delhi, but previously he had a term as a director at IIT Jodhpur. Also, he was a director at the CSIR Institute, which is on Central Electronics Research Institute, and he also served as Dean Undergraduate Studies at IIT Delhi, and he has held the number of chair professor positions at IIT Delhi. In the awards, he has been awarded the INSA Medal for Young Scientists in 1993. He is a fellow of the Indian National Academy of Engineers (INAE). He's also a member of the National Academy of Sciences (NASI) and International Association of Pattern Recognition. He's a fellow of the IAPR. Um, he is also a recipient of the Distinguished Alumni Award from IIT Kharagpur, with over 350 publications in reputed journals and conferences, 15 patents, with technologies commercialized by global industries. Certainly, we are very happy to have him here. His um, research interests are in computer vision, AI, digital heritage, AR, VR, and multisensory media. Okay, so
Good morning. I think we are delayed, but I think for circumstances beyond our control. Okay, I think I've slightly modified my topic in the sense that document AI, and I'm really talking in terms of document analytics. And document analytics in a more generalized sense, because today, if you see, we talk about analytics, we talk about data, and we typically look at data in a very unstructured way. Document is also unstructured, but document content has an inherent logical structure which comes from our compositional principle. So it is not just random data. So if I take a experiment and just doing a measurement, we are getting a sequence of data, but there is no logical structuring of the data other than the fact that they are outcome of an experiment. But when you look at a document, the basic content may be in that sense unstructured. It is not tables, but it has got a logical thinking which has gone into it. So it is in some sense structured. So now therefore when I talk about document analytics, it is not just interpreting the data in the document, but also to interpret the logical structure which has gone into construction of the document. Therefore, the problem is of a different kind than that of standard data analytics problem. So I shall try to address that issue, and that also is a very interesting area altogether. Next is, yeah. So let's try to define what we mean by document. A document, that's why this is a generalized definition of a document. A document is a written, can be drawn, can be presented, or memorialized representation of thought, often the manifestation of non-fictional as well as fictional content. Okay? And content in different forms with a variety of layout, sequence, and attributes. So this word, if you see documentum, or that is a Latin word, denotes a teaching or lesson, and verb docio denotes to teach. Therefore, there is an inherent communication in the document. And contemporarily, document is not defined by its transmission medium, that is paper. Its existence can be completely in electronic form also. And document also derives importance in the context of other documents. So it's a connected world of documents. If you see and if you look at, when I have a library is just collection of documents, and it's not necessarily a connected world of documents. But when we actually do a library work as a researcher, we create a connected picture of the set of literature for our purpose. So therefore, document has got that connection. So it's not document analytics, is not necessarily a single document made stuff. So connected documents have explicit or implicit connections. So this exactly gives me the point where document AI is more than data analytics, more than document analytics per se, is that refers to use of technology of automated extraction, classification, cross-linking, and understanding of information with presentation formats, that may be from web pages, maybe from digital bound documents, maybe scanned documents, or multimodal interactive documents. So therefore, if you see today, our space of documents and the way we create and express our creative thoughts or scientific thoughts, that medium is large. And if you look at this collection of our thoughts, and I want to distill out of that collection and want to process and present, that actually is a problem of a different kind altogether. So therefore, different kinds of techniques comes into play: signal processing, computer vision, natural language understanding, multimodal data analysis, and analytics principles. And in fact, it's very, very important to see that classically document analytics, you will find that refers to using document image understanding, which was actually a computer vision problem. But the moment you look at it And where it is moving today is actually a much more generalized and much more challenging problem. Okay? So automatically reading, understanding, analyzing, linking documents, that's exactly what is very, very important and critical. And multimodal document is today a very important and significant data component in our world of any kind of academic activity. Yeah, so if you see, these are all examples and of documents, but what is important I want to show is that if you look at one level, those who are doing earlier document image analysis, the problem is that of analyzing the layout. But these documents cannot be understood if I don't have a background knowledge. So therefore, the background knowledge and how we incorporate and put in the background knowledge for its own understanding becomes a critical component here. Because I do not understand, if you see, this actually is a big problem if you look at today is being talked about, contract management. If you look at from an industry point of view, there are lots of big industries are looking into how to have their contract database, how to synthesize a new contract for a customer, which is consistent with the government policy, and how the contract clauses can be also specific and hidden. So now, if I have a contract, then I need to understand the contract and then generate a contract from that contract. So it is a purely commercial problem, but there are huge technology challenge because you have to understand the contract, that's a interpretation, and you have to generate a contract, that's a problem of generative AI. Okay, so therefore the document analysis, that's what I want to show this example as, that it's actually spans across the entire range of intelligent technologies that we are talking about. So therefore it can be structured tables, processing documents, there can be approaches for sales data analysis, therefore it's a table analysis. Today if you see that there are completely a range of papers which are coming out, technology which are coming up, which are dealing with tables in different form. We see PDF tables, but you give those PDF tables to a computer to analyze, it's not easy. Okay? Then you see the semi-structured records, electronic health records. Electronic health records has variety of things. It will have handwriting, it will have structured data, it will have image. And if I want to do any analytics based on electronic health records, the first step is I need to have the ability to understand the record. Okay? Then there are organized data collections, say for example scientific publications, legal case files, news, social media. In fact, today I think the current OCR project which is going on, a major objective is to actually look at and understand parliamentary documents. The documentation of parliaments and state legislative bodies have used huge document data. Now, any reference to a parliamentary bill which comes, it has to refer to past bills. The whole thing happens manually. But today, with so much data, see after 75, almost 75 years of freedom and constitution and everything, the volume of documents somebody has to go through is humongous. And without digital technology, nothing can happen. So all of the assemblies now are looking into digitization of their documentation, indexing and a search mechanism. And that's also a very interesting problem because this also opens up commercial possibilities. Because each of these legislative assemblies, state assemblies, they do their business not just in English but also regional languages. Okay, so therefore, how do you actually interpret regional language legal documents and tell that whether there is a precedence, there is a violation, everything. If you see even Supreme Court, there has been contradictory decisions with reference to not being able to refer to correct precedent case decisions. There is documented evidence of that. So it's actually a very important and critical component of even continuance of governance. So therefore, these are all kinds of problems which you are there, and these are all originates from this domain. And if you look at labeling challenges, universal representation of heterogeneous inputs, knowledge constrained interpretation of contents, domain transfer, explainability, and possible bounds of error. In fact, these two parameters are extremely important to build what we call dependable document analytics system. These issues we have never addressed before, because now when we are talking about referring to a court case or a parliamentary bill, you have to make sure that you are not making errors, if you are making errors within a bounded probability. And there are heterogeneous types of documents and structure and semantics. The interesting part is, if you say NLU, a natural language understanding, natural language understanding or the interpretation of a language construct is actually a sequential data. In natural language understanding, the format of representation is not there. Today, the entire LLM, which has come up with your generative models and ability to model language as a huge autoregressive structure, and based on that you interpret and you generate, in that whole framework, the representation or the formatting, structuring of the language constructs is not there. But when you read something, the structuring is also a very important element to understand and interpret. So this is today's bottleneck or the gap in the natural language understanding. So this is an example. Say, look at this document. If you give this document in electronic form to LLM, what it will do? LLM doesn't understand or interpret this layout. Okay? This layout is a critical element of these if it has to be used for any purposes. And if you see, there are text reconstruction with the layout, so therefore there are different parts and different problems. If you see, and if I have to interpret them, these are all. If I say that what is the date on which this was generated, then I have to interpret the box, and based on that I have to give the answer. I have to interpret the layout to get the answer. So I have to do the layout analysis to get the title, and I need to do possibly masked image reconstruction to find out the shipping date. So if you see, just interpretation of these simple an invoice or a receipt requires to solve vision task. If you have to solve these mixed task, okay, the layout as well as the vision, then purely text task and purely layout task. So a simple receipt in digital form, or even just an invoices which are maintained in digital form, if it is to be interpreted, simple natural language understanding doesn't do the job. It has to be a multimodal. So these are other examples. If you see this form, if I have to interpret the form, it's a medical record, the form and there are different data, and these can also have, this is written, this can also have handwritten. You have to identify the field and say, and know what it is. So the key point here is, given if these are the fields, I need to know the semantic entity recognition. This problem is that of semantic entity recognition in a structured document, where all of this knowledge is there. And if you see, this is a content analysis in different forms. Different types of tasks present in document images that we need to address. So obviously, this is much more generalized way to look at things. And particularly if we look at historical documents, the challenge with handwritten text, challenge with noise, and this is completely unstructured. How do you interpret this? How can computer extract information out of this? So you have to go through, if I am looking at newspaper records of last 50 years to see how things have changed, any analytics, okay? So for example, there are lots of issues now coming up in terms of different subcasts, caste and their growth and their potentials. These are all politically very, very sensitive issues. You have to do a kind of an absolute objective analysis over 50 years record, okay, or even more than that, and what has been reported in newspapers and other government documents. Now, why I am trying to establish all of these is not an esoteric scientific field. It is a field which has got tremendous practical applications. exponential. So there are so many young people. So I think they should look at and think about those things. Now the key technology today which is coming up is also in a way has got aligned with the development of these LLMs and chat GPT and that's what is the key point over here? The key point of this technology, if you see the attentional models, the transformers, okay, and this self-supervised learning. Now if you bring all of this together in a different media form, these are the key techniques which are being used here and has to be used here in an intelligent way. Okay? So that's exactly what is being done today to have this whole thing be worked out. So if you see generic document, if we now look at, try to think in terms of, we use what? In language we use pre-trained models, we fine tune and use it for different applications. If it's a foundational model, we shall use a prompting, that is in context learning, to get things done. Now this document image understanding is also has moved into this process of system development. Okay? And if you look into that, if I look at pre-trained model, if I want to generate pre-trained models, so these are these kind of, I can have these multiple pre-trained models. These are different conditions, okay? So I can do semantic entity recognition, entity extractions, and we can look at both structures and unstructured handwritten text. Then we can look at document classification. We can look at noise removal. Now, what is that showing you? Just like a foundation model is trained with huge number of data, okay, huge number of documents or data. In document image space also, we are trying to talk about that we shall deal with different kinds of tasks. A foundational model gets pre-trained with multiple tasks and then you tune it, so then you can use it for task level applications. Okay? So the architecture, the way we are talking about today, I think we are familiar with the multimodal systems. See, multimodal foundational systems, and if you look at from their architectural pattern, this document image understanding is actually an instance of that architecture. That's what we have to build. But there are not many things which are really available today. And all of us know, say, BART. BART model can be used. That was essentially, if you see the mask language model, it was, and from BART to BRT BART, which was more auto-regressive. But look at BART. BART was simply a mask language model using self-supervised learning to learn the language semantics. The question is, now can I extend that model to learn a form semantics? Okay? Because I can mask the field and then try to predict the field depending on the data. Just like I do it in a language, that is, I have a sentence collections, and there I mask the words and learn to predict the words, and that gives me the relationships. And that also defines my attentional models. Fine? So now that's exactly what we tried to build this kind of vision language transformer models. There are people who have worked on it. So these are masked OCR tokens. OCR will have huge contextual values. Okay? So I can have masked OCR to train the OCR to do correct predictions. Okay? So masked OCR training. But masked OCR, if you say Indian language models, the characters are not one dimensional, but they are two dimensional. Okay? So you have to look into kind of a 2D embedding absolute position and relative embedding. This is actually how do I construct the embedding for these kind of masked OCR tokens. Okay? It has to be 2D embedding box, that relationship. It's absolute position embedding and relative embedding. Okay? So I can actually represent all of these with respect to a representational space. It's like we do a locational data gets associated with a feature token I can do this locational data, but this locational data becomes much more generalized. And then if we look at how do I train, so I have these masked OCR tokens and I have these masked bounding boxes. Now why OCR tokens and masked two bounding boxes? Because OCR is a character prediction token. Okay, I'm learning to have the characters. If I know how the characters come one after another, that is the masking part. But also I need to know the word layout with reference to the document layout. So that's why masked bounding box. Okay, and to this we have combined image features, which can be also connected component. In fact, image features, because image features also tells me predictive model to get the correct prediction, because I need to know that what is contextualized with respect to other words. So therefore, in a language model, you will do a word masking of the words. But when I am doing the character recognition for the words, I have to mask the character with reference to the word. Okay. So therefore, I am doing a, so therefore, this is a masked OCR tokens. Okay. Masked bounding box tokens, because that's giving me the word boundaries. Okay. And then I have about the image features, because image features can actually give you that if it's a shaded area, then how do I use the image features, and based on that I can do the predictions. Okay. So what I'm trying to show is that the way the vision transformer works with the visual features or video features, I need to look at today a document image analysis, or document analysis for that matter, a kind of a transformer architectures, and learn these predictions, which really gives me the attentional models to understand the semantics, and based on the semantics to do generation. Okay, so these are, and there is a very nice, this FunSD data set on which you can work and get, and we use these and we got some sort of results in that space. This is a paper this year's IGDAR that where we got this work reported. And if you see, there are also predictive results, because this, on the basis of predictions, if you see, there is also distortions. Because of the predictions, I can actually do correction modulo the distortions, because if I have this set of documents, I have the model of distortion. I'm not mathematically pre-modeling the distortion, I'm learning how to correct the distortion on the basis of prediction models. So these are all classifications of different data and what we have done, and this is, if you see that, so what I'm showing here is not only just prediction, but using same model, I can also classify the documents. Okay, so now I generalize my attention model, and I define my attention model not just with the box, but also the connected component. Why connected components are important? Because when I'm looking at an Indian language recognition, I have, say, the joint characters, conjoint characters, we have these matras. These are all connected components and two-dimensionally connected components. And if we can define an attention model on those connected components, I actually learn the context. Attention models are nothing but context, because of which I can do a better language modeling. Here what I'm trying to say is I am doing a better script modeling, that's handwriting or a printed script in different language, the modeling brings that context. And that's the most interesting part in terms of, if you see that embedding and this attentional model is now being used for all the media. Starting from, it started with language, it's being used in vision, it's being used in speech, it's being used in other signal processing tasks, and in the similar way, it can be used for this kind of document image analysis, handwriting analysis. Only thing, the primitives that you use are different. Your attentional space, you need to define so that to get results. Using we had to handle complex layout and other stuff, and using this kind of with this multi-headed connected component attention and multi-headed connected cross-component attention, and building up this transformer with the connected components and using multimodal attention and get a better interpretation of results. So this is the architecture that we use, and because the ground truth is not there, so in many cases we used unlabeled data set to train on the basis of self-supervised learning. So if you see to it that if this is a kind of a complex layout, and this can be a language independent kind, this is a data result from a Bengali document, this is a result from a Oriya document, okay. So that means this can be a language or script independent technology can be really developed around this core concept. So these are quantitative results, and it's basically if you see that what is the state of the art and what we have got. So now people are working on Doc AI foundation model, and Microsoft has worked, and in fact 2024 paper is there that multimodal document foundation model layout XLM. This is for multimodal pre-training for multilingual visually rich document understanding model family. And I think the question right now today is we possibly need to work on creating foundation model for Indian language documents, handwritten styles for multiple tasks. Because what I have shown is that this kind of pre-trained models and fine tuning are feasible, and it's possible for analysis of that. And I think today this, I do not really, this Bharat, that model which is this Bharat LLM, that project which has initiated, whether they are looking into handwritten. I know they are looking at Indian languages, but document I'm not sure whether they are doing it. But if you see, this is an interesting architecture. This is multimodal transformer encoder layers with spatial aware self-attention. What I was talking about, okay, that actually has been now expanded. So our paper was this year's in IGDAR, and this year in 2024 archive you will find this Microsoft's this foundation model in document. So this is really coming up and a very exciting area to look at. If you look at intelligent document processing, these are all different components which comes up, and these are got associated. And why I wanted to show this is also even the commercial entities are showing that this cumulative growth rate of about 35.28% during this period, because this is a commercial possibility also. So it's not that pure academic research. There can be lots of, maybe 10 years back or 20 years back when we started doing OCR, these commercial possibilities were not apparent. But today it's very clearly these consultancy companies are predicting this commercial possibility. See, tabular content analysis and table transformer is one, and this is actually a work that we are doing. I have masked this out because this is for an industry that we are doing right now, using the tabular data and basically trying to use the tabular database kind of a pre-trained model and use that for different commercial tasks. Particularly getting, say, customer data and using the customer data, and we use it for, because customer data comes in various tables, and we need to deal with those tables. Okay, and based on that, if I want to do a campaign, a marketing campaign targeted, I need to understand the structure of the table, components of the table transformer as a basic building block, and also what we are trying to do is that a kind of a federated model, because I have tabular data from multiple sources, and have a federated model based on that trying to generate a kind of a campaign, a marketing campaign. So this is what we are trying to do with one of the industry. I thought that let me just touch upon it, because this is again a document data. This is a tabular data, is essentially a document data, but just look at it that using data in Excel, okay, the structure of the table is being exploited, not just the data sequence. So therefore, there has been various approaches. This is one of the earliest work which has happened, and I think I just referring to, and then you can have document processing over there. so let's look into the consumer tools. That this is kind of a today, I think, number of state governments. This is again something which is coming up in a very interesting way. Number of state governments today are looking for this automated correction of examination scripts. And if you see today, your CBSE use a computer-based corrections. They scan the documents, and scanned documents comes to the school, and the teachers go through the pages and give marks. So I think there is a huge interest across to automate that process. Okay, and even if you can do semi-automation of that, there is a huge market for it. In fact, they are actually looking at, I know of at least 2 state governments have actually asking for proposals to look at that. So these are not, so now let's look into that information extraction. We just talked about the processing, interpreting a document. Okay. Now interpretation of the document is not end of the story. Interpretation of the documents is the starting point of the story. The more important aspect of the story is extraction of information from the document. It can be extracted from a single document or document of documents. This is something very, very important, or document of documents. So therefore, extract insights from document repository or extract information. And if you see all of these, say multi-document summary, how important it is, let's say policy matter, all news related to Delhi pollution 2024, not 2204, but 2024, okay. And then causes for heart attacks in young adults. Because we have seen in recent times number of reports of young adults losing life because of heart attack. Now, if I have to do an analytics on that, I cannot search and do it on my own. A medical informatics required to have techniques to unearth this data from variety of sources. So all of these are actually problems of document analytics. So if you see, therefore, now NLP has to be adapted for document analysis. What we are talking about in fact in terms of a standard NLP, and what LLM does simple query answering on the basis of what it has got from the data that it has got, that it's there. But now it's not task directed. So what I am trying to stress upon is where is LLM today and where is the gap based on what is required. So LLM is not the ultimate thing in terms of natural language processing, so we should keep our hands closed and stop doing any work. That's why this document analysis is very, very important, because document brings in structured data, structured linguistic data, and we need to have the ability to interpret and exploit structured linguistic data. So therefore, if you see linguistic analysis, you can always do. These are all tasks and which are there already happening. Now you want to do statistical reporting on all of this, and also you can have a variety of generative applications around it. And what is natural language inferences is conclusion. See, LLM gives report, doesn't give inference, because LLM can also hallucinate. There is no validity in terms of natural language inference from LLM, because that's exactly another open problem to look at. So therefore, all of these are important and to look into it. So you need to have these are the challenges over there. Okay, if you see custom NLP components needed large volume of annotated data, handling non-uniform structures, multilingual code mixed content, domain customization, and generation of text, all of these in terms of directed way, none of these LLMs can do straight away. Okay, those who are familiar with LLM, you can very clearly see that they cannot be done directly by LLM. So what I am trying to say is that I shall show that LLM as a component. Okay, if LLM is available, because see, the point is I cannot generate something equivalent to LLM because I don't have resources to do that. I have not been able to say I cannot go through the entire internet or entire libraries, but people having lots of money can do that. If people can do with lots of money, then how can I build on top of those money? I should have the intelligence to exploit that money. Okay? in terms of technology and technological innovation. So there are huge number of problems which we should look at and not say for everything that LLM will do it. And this is actually also another problem that when you go anywhere, experts, we are also belong to some of those categories, but they say LLM is doing, why do you propose such a problem? Okay, this is something is a major problem today. We work with half knowledge. So if you see that there are now LLM are one-stop shop for all of these, right? But there are many problems that I've highlighted in the previous script, which can be addressed once you have this one-stop shop with us. So this actually generalizes the whole definition of document. Say delegate your NLP tasks to ChatGPT. That's a standard thing we do. Say for example, a restaurant review analysis, and it can be conversational, that is summarize the above, so you can have. So this is an advantage of what LLM can do, what LLM is doing. Now look at this. Using LLMs instead of customized pipeline has all these benefits today. And that's why it actually is so popular and useful. So this is something we need to understand. If you understand this, then we know how to exploit it. So therefore, if I do this kind of document repositories, you set up tasks, map to features to be extracted from tasks. This can be done through LLM. And to do this, you actually do a prompt LLM, output in a structured format. Once you get that output, you can create a database, store output in database, analyze and generate reports. Therefore, this point is what LLM I am exploiting LLM. First is how do I database, analyze and generate reports. This is what I am doing using an intelligent, maybe knowledge-driven system and using LLM as a component. This becomes a kind of a generic architecture. If I have a document repository, I can analyze the initial phases of the document repository analysis. These are going through the LLM pathway. Towards this, I can have my own pathway and add value to this. So using LLM as a component. So if you look at LLM, this with small context, LLMs are not best tool for count, sums, average. This kind of statistical insight generation. LLM cannot do that. And also, if you say that, this is an example, there is negative sentiments. How much of negative sentiments? LLM can give these are the negative things, but what is the frequency? How many negative sentiments? this is a market. Now, if somebody wants to generate things on a regular basis, he has to have a knowledge source. And this is an example that if you want to do a play on Indian cooking to make it more healthy, how can you use LLM? Okay, it's a problem of two different domains coming together and interacting. So you can get these ingredients, measures, quantities, and now the whole thing comes up in a structured form, the database, and based on that it can be a actually recipe, but it was originally a web story about food blog. From food blog you transform it to a kind of a structured thing from website to database. And then you can build a food knowledge graph for India. And it's absolutely, if you see the diversity which is there, we don't know about our food habits. We do not know what are the different kinds of grains we use, the diversity of grains, the essentiality of diversity of conservation of those grains. So I'm just connecting what is that this space actually spans across knowledge domain, and that's exactly the power of document analytics. So full knowledge graph and multiple sources. See, therefore, from LLM, using web, you generate knowledge graph, and then on the knowledge graph, you can run your query engine and you can provide those inputs to the users. So food composition, knowledge base, everything you can happen. I'm not going into it. So eat to eat or not to eat. So you can actually get all of this data, and based on that you can decide whether to eat something or not to eat something, and all of these. So all dangers and all these things can come up. This is not experimentally done. What I'm trying to say is that no experiment has been done. It based on data which is available, and from there is a authentic sources, which are claimed authentic sources, cross-verified as authentic sources. So now, if you look into it, therefore, now if you see now as LLM as a component, and if I have LLM as a combination of LLMs, because each of the LLMs doesn't give identical answers. So when we used to talk about expert of experts, multiple expert systems, think in terms of LLMs as tools for this kind of information aggregation. So if you see, you can do that, is maybe personalized health, mental health, actionable intelligence, and therefore you can exploit food websites, social media, legal documents, sustainability news, and you can do that through number of different LLMs, deals with multilingual content, and then generate this. So this is not automatic graph. This is a structured way of solving problems, creating layers on top of the resources that you have. And that opens up, this is just one example, that opens up in a variety of domains, because your internet is a huge knowledge source. How do you exploit that in more effective way? So at these, obviously there will be hallucinations over there. So now how do you deal with hallucinations? That fine-tuning, chain of thought prompting, retrieval, augmented generation, and validation against factual databases, human annotated data, and human evaluation. So therefore, I use an ensemble of LLMs, aggregate, then I do paraphrase prompts, compare answers, and validate, cross-examine over multiple answers and validate. This is actually to check whether, with expectation that all of the LLMs are not hallucinating at the same point of time. Okay, so you can use this is exactly the same thing where you used to use multiple experts to come to an answer. Okay, so similar kind of a modular approach with the multiple LLMs we can do, and therefore we have ensemble of LLMs, respond, feedback, and if you see here, you can also have this reinforcement learning, which is already if you see today, it's RLHF is already there. Now, what I'm trying to talk about is we have tried on that using RLHF on the basis of multiple LLM feedback, not a single LLM feedback. Because I may not know what is the correct answer. If I know correct answer, it's fine. But on the basis of that, if there is an inconsistency, now generate a reinforcement signal on the basis of inconsistency and not correct or wrong straight away. So these are obviously, we know, but this is an open problem, and this is what we need to look at, and therefore how do you use, this is where the current use of LLMs are. So what we are talking about is how to use this is a kind of decision making system. How do I construct a decision making system using LLM as a component? So let's say, let's look at an example as agricultural policy. I think I was waiting for you to come. Okay. So if you say that agricultural policy in India, how can I form a critic of agricultural policy using all the documents and using LLM and these kind of tools to look at it? Policy making needs data-driven answers to various questions. Some of these are how climate change affect crop nutrition over the years, how is crop nutrition affecting public nutrition, how is public nutrition affecting public health. These are core policy level questions which are linked to the agriculture and what interventions should really happen in agriculture. And in fact, I picked up this example keeping you in mind. So I was just waiting for you to come. So, so if you look into this, now this is a very interesting problem that this is cross-modal, cross-domain, dynamically changing, and data is spread across disparate data sources. That's why this is a very challenging issue in terms of policy making. So now, therefore, if you now look into it, everything put together, can I create an agentic system to take decisions with minimal human supervision by analyzing data, set goals, and take actions to solve them? Okay? And so agents are designed for different types of tasks: multimodal data analysis, knowledge discovery, causal reasoning agents, because I have to have causal reasoning. Because right now, the causal reasoning element is missing in the LLM altogether. So I need to bring in the causal reasoning as a layer on top of that, because causal reasoning can be domain-specific causal reasoning. LLMs are not domain-specific in general. And so, therefore, I can have these kind of a model to work on. Okay? Say I have databases, domain-specific repositories of content, world knowledge, existing LLMs, and then I can do an information analysis agents, information curation with source attribution. Then in fact, cross-domain links, this is knowledge discovery and causal reasoning and decision support, which goes through prescriptive analytics platforms, generate plans, reason with counterfactuals, and simulate future scenarios. So we don't do, when we do planning, we do imagination. The policy making is actually the biggest problem of our policy making is this. But if we can use a causal reasoning and do counterfactual based simulations, we can actually construct various scenarios with these generative AI formulations, using this LLM based knowledge as a basic input. Okay? And this is actually can have a huge implication. In fact, we have tried a simple example. I'm giving a framework. We tried a simple example. It was, we are looking at transportation in the city of heritage part of the city of Jodhpur. Because transportation pollution is impacting the heritage buildings. Right? Now, the problem is, if I want to, my constraints are what? I have to preserve the heritage building, but I cannot impact tourism. Tourists should come to those places. So given these constraints, can I create a graph network and augment a generative model based on graph network to show how the alternate traffic planning can come? Okay, which would say, for example, if I'm using some roads should get converted to walkable zone, some roads should become one way, somewhere the traffic should be controlled. So it's a multi-constrained problem. and I can represent the constraints as a graph neural network, and based on that try to generate solution, and those solutions actually I feed in to a kind of a generative model to create scenarios. Okay, the scenarios are actually simulations, and see the simulations to actually validate what we are getting is good enough or not. We did it a small, very small amount of data collected, but this is the kind of an approach if you see today with your, so therefore, why I am telling is because these data can give that background information. And based on that, I can do this counterfactual based simulations. This is a causal simulation. That is, what if? What if I want 4 o'clock in the evening to 5 to 6 a walkable zone for heritage buildings? Okay, and that is the counterfactual. That given this current situation, what if this would happen? And there can be many counterfactuals. I can actually look at counterfactual distributions to come up with most likely plan to succeed. And this is the basic principle of today's causal reasoning, causal modeling. If you see structural causal model that I have not referred to, what I am referring to is use LLMs which are not causal. LLMs are essentially associative probabilistic mapping. Autoregressive modeling is what? Associative mapping. And to that add a causal layer, which is a problem specific causal layer. Okay? So that actually enables you to deal with the whole space of document driven knowledge to an actionable entity. That is, from document generate an actionable insight. So if you see, look at from this agriculture point of view, all of these scenarios to be looked at, because these channels of information are not just the government channels, and possibly the most maybe one of the most noisy channels are purely government channels. Okay, so if you want to use a public channels, government channels, and all of this together to come to a model and simulate and project, this today's technology provides you that option. And that's a document analytics actually, because these are all documents. These documents you need to actually interpret, analyze, and come to decision making. So therefore, if you see now, the outcome wise, what we are talking about is, can I do something like this? News, agricultural policy documents, food and dietary data, scientific publications. I use LLMs, RAG, KB, and all of these agentic models that we talk about putting together. Can I create a dashboard which talks about all of this together? It is not something which is impossible. Today, given the data, you can define a domain, you can define a state, and actually you can use all of these things to come up with not a human planned systems, but a machine planned system which may be objective, and maybe may hallucinate. That's why I'm bringing in the causality, at least causally valid system. And these are some of the things. This what we are talking about. This last part is an ongoing work, but we are trying to do that something as a limited space. But this is viable and feasible. And if you look at agriculture, a particular domain of agriculture, if you want to look at, say, a crop cultivation and look into the whole ecosystem of that, because today we try to look at disease in isolation, fertilizer in isolation, but if you look at completely ecosystem, environment, market, demand, okay, and financial condition, financial supply, and work out a strategy, how to synthesize that strategy using AI as a tool. And I think that's possibly the biggest possibility of AI for social good. So, in fact, people have talked about doc AI in designing of smart cities. If you see that how the urban environment, because there are lots of documentations, lots of reports which has come in. Okay, now how do you use them? In many cases, we look at and we find there are research proposals being given doing the same thing, but they say that is data in the document, so I don't have structured data to analyze. statistical analysis, I should go and do a field survey. But the point is, if I can interpret that data, I need not do the field survey. This is an open area which is turning out to be very important. In fact, if you see, even IGDAR also, there have been lots of discussions on old documents, understanding culture, have a better insight into the culture. I've talked about more policy, I've not touched upon this at all, I won't get into it. But I just indicating it, people who are interested in not maybe agriculture or medical domain, but say on culture, there are so many historical documents which are available, the documentations which are available and which are not on internet. LLM partially looks at it, which have been recorded and documented, particularly in terms of a group of researchers who have written in English, but there are huge amount of this documentation in native languages. How you combine the two things together to get a better cultural insight. And it's, see, the volume, the problem is in all of these cases, the volume is a challenge. And because of the volume, actually you get an individualized viewpoints. Can you cross that barrier? Today these tools enable you to cross that barrier. In fact, digital humanities is a discipline which is emerging using of all of these tools and techniques in the space of humanities to look at these problems. So it's a cross boundary. Okay, so computer science to say agriculture, computer science to humanities, that whole cross-boundary travelogue you can compose if you look at document analytics or doc AI as an area to explore. This finishes my talk. These are some open issues. You can think about it. Thank you. If there are time, I shall be very happy to answer questions.
Yeah. So, thank you for a really stimulating talk. Right. Questions means like there are plenty of questions which should be there, but any specific directed questions? Yeah. Yeah. Please, Professor Vinith. Yeah.
So thanks for that beautiful talk. You have actually given problems for the next 10 or 20 years probably. But I have a few doubts in my mind which I would like to clarify. So and basically it is about the multi-model framework you were talking about. So I work in the area of visual language modeling. So one of the problems I found there is, for example, given an image where an image of a building is there. There are around 60 floors there. So the current image understanding as well as caption generation, it will actually tell what kind of building is it. But if I ask how many floors are there, this would probably be a difficult problem. And I don't think it's the causal reasoning part or any of those which could actually justify such things.
I'll take that question first. Yeah. Before you go to the next part. See, the point is, that's exactly why I'm talking about that. It's precisely the reason why I was talking about using multimodal data. See, because the number of floors you cannot get from the image, fine? But you have a news item which can talk about that number of floors. Okay? Or there can be a report, a municipal report about the number of floors. So if you want to really use any practical application, it cannot be just a multimodal LLM to answer your questions, but you got to have a multiple nature of the data to be combined. If you see what I have talked about is using LLM or multimodal LLMs as components, add on your knowledge, add on the other documents, combine the things together and generate the answer. So if you say, if I have the data about that image, so image basically would have also the data related to the location. Location wise, there will be maybe a municipal records if it's accessible, or maybe data on the internet. If you see all cities, major cities, the data is on the internet. Okay, so now if I scrape internet in that exhaustively, which LLMs are claiming to be able to do, and based on the query and cross query verification, can I generate this kind of insights?
So now a small query attached to that is, this is always there in my mind, because earlier I tried to do research and reasoning, and then I went into machine learning. So when given such an image or a document which has both language as well as image, do you first try to reason or learn about the language part? So I mean, this is always a confusion.
So what I'm trying to talk about is that what we have done, actually try to separate out the components. Okay, then try to discover the relationship, and then comes a reasoning. Okay, because I cannot see, if you see that, see where the reasoning in recognition comes. See, typically if you use a ML based recognition or even that classifiers, it's based on a distribution. If you say ImageNet, take just ImageNet. ImageNet can do recognition, object recognition, possibly the best tool that we have. But if you change the context of an object, it cannot recognize. Say a dog swimming, it will not recognize as a dog. Because what it has learned, dog, is that associations of the dog and environment and all these images, over that, it has learned and generalized a distribution. The example that you are giving is not in the distribution. Okay? Out of distribution. So that out of distribution, all of these classifiers will fail. If you have to deal with out of distribution, you have to build a causal model of recognition. So if you have built a causal model of recognition, you can go through counterfactuals. Okay, and going through counterfactuals, you can argue that because of this reason, this is a dog. Okay, so this is the causal part. Whatever we are doing today and what LLM is giving us, actually these associations and huge associations. Okay, and ability to synthesize things because of these associations. Okay, and why does it do this kind of hallucination? If I ask, say for example, that who is Shantanu Chaudhary, LLM can tell that he is director of IIT Delhi, because I walk in IIT Delhi, I was director of some IIT. Okay, so it will be another association. So that's a clear-cut case of hallucination. So this is the problem of LLM. Now I need to bring in the causality, that is causality in terms of, that is, if this is, see, just look at A implies B. Given A, it is B. But given B, I cannot do A. If I have to conclude A, then I have to do this causal reasoning, which actually go through counterfactuals. What if? And based on what if exhausting what if, I would really come to the conclusion, what is the most likely cause for B? That's a causal. Now that reasoning is actually much more structured and not just associations. LLM has associations, so it's building third association. And that's precisely the reason why it hallucinates. Now since I've done huge amount of associations, number of refinement of those associations, so hallucinations are gradually coming down. And that's why even if you see that all of these reinforcement learning is built in, what we suggested here is that reinforcement learning on base of multiple elements.
Thank you, sir.
Yeah, Chakrut. Yeah, I have two things. One is something about machine unlearning in the context of document analytics. The second is about mis, dis, and mal, and such kinds of information that we can analyze through the documents. So I would like to hear some comments on that.
The first one is, you talked about, see, let me answer the second one and you come back to the first one. See, the problem is that malinformation propagation, that is precisely the reason what we were trying to talk about is multiple LLMs. Because all LLMs may not really look into the same source of data, may not build the similar associations. But if I infiltrate my way with lots of malinformation, if I use that web as a source of data, I cannot escape through any of these means malinformation. Now, if I have a cross, that means the point is that if you see, I have also shown that it's not LLM. LLM is a component. I am also bringing in other documents, evidences, surveys into the picture. That's the only way to actually counter malinformation which is there on the internet. But if it is there, if I use only with LLMs, it's extremely difficult. You can only increase your chance of filtering it, saying that multiple LLMs may not get into the same source. Okay, the first part of the question was? Machine unlearning is, yeah, so the point is that, see, so I'm not talking about machine unlearning. What we are talking about is drifts. Okay, because changing the documents means there is a distribution drift. If there's a distribution drift, these ML systems will definitely fail. The question is, today, do you have any system to deal with that? Say, for example, today, look at that edge intelligence IoT devices. And when you build a classifier on the IoT devices, what happens? Temperature, the moment temperature changes, the sensor sensitivity changes. If you do not compensate for that, it will generate completely wrong signals. So therefore, you have to compensate for it. Now, there are also temporal data. So when you are having a temporal data and you are doing a prediction on a temporal stream, you will find today there has been lots of algorithms which has come up which actually finds out that when you find the error between the prediction and what you observe. See, you have predicted something. So it's a sequence of data coming. You have predicted the next sample, and when the next sample comes, you look at the error. Based on the error, you actually change the classifier. And in fact, you actually make it into this is a kind of supervised learning, and make it into a supervised and reinforcement learning combination. So use, say, many cases people are using multiple classifiers and mapping that problem to multi-armed bandit problem. Okay, so how the multi-arm changes with the drift. So these are all techniques for handling the drift. Drift is a very major problem that you can't do anything with. No, 10 to 10 years. Actually, next 5 to 6 years, I think lots of problems will come out of this. Absolutely. In fact, I tried to touch upon, I talked about some of these things also.
Okay, so thank you very much, all the clarifications, and we bring a close to this session.
Now we'll have a very quick break. Okay, so probably let's take only 10 minutes. Okay, so 10:45 we'll start. Session.